In this video, we're going to be learning some basics of molar math, how to convert from different things to other different things using the mole. So in converting between mass in grams and moles, you must determine the molar mass, which we reviewed in our last video. Molar mass is used as a conversion factor to convert between the units of grams and units of moles. This is because molar mass is the mass of 1 mole of something, so the conversion factor can be written either way. Either we can put grams on top and moles on the bottom, or we can put 1 mole on top with grams on the bottom. Now the number with the grams is going to be whatever the molar mass is, but it will always be 1 mole. When converting between mass, grams, and moles, you're going to look at the units to determine which way it goes. So this is going back to our dimensional analysis that we learned about first semester. So converting from moles to mass. So you're going to use your molar mass as a conversion factor. So let's do this one together. What is the mass of 0.045 moles of NaCl, sodium chloride? First thing that we're going to have to do is we're going to have to calculate the molar mass. All right, so let's work this one out together. The molar mass of NaCl, the mass of sodium plus the mass of chlorine, no multiplying needed, we get 58.45 grams per mole. Great. So then we just set up our dimensional analysis. We put the 0.045 moles of NaCl first. That's what is given to us in our problem. And then we're going to put our conversion factor. 1 mole is going to go on the bottom because we want moles to cancel out. So if moles are on the top over here, we need them on the bottom over here. Meaning we put our molar mass, 58.45, up on the top. And then we just multiply across the top to get to 0.63 grams of sodium chloride. Pretty straightforward. This is just like easy dimensional analysis, which we already did first semester and reviewed here. So let's try another one. If a student measured 0.0 grams of sodium chloride in lab, how many moles do we have? All right. Either using our number from before or recalculating it, molar mass of sodium chloride is 58.45 grams per mole. Once again, we're going to start our dimensional analysis with our number given to us in the problem, 0.25 grams. So this time, that means we're going to flip the conversion factor. We need grams to be on the bottom, so grams can cancel out. So we have 58.45 grams of sodium chloride under 1 mole. Same deal as last time. This time, we're going to take 0.25 and divide it by 58.45 because it's on the bottom. And that's going to come out to 0.00438 moles of sodium chloride. Now that you've got the hang of it and done them in both directions, I want you to try some on your own. Pause this video and come back after you've done A through F. Seriously, pause the video. Just getting the answer is not going to help you. I'm not going to show you how to work it out. I'm just going to give you the answer, which doesn't help you at all if you didn't try it on your own. So pause this video and try these on your own. All right, check your answers and see how you did. These are the answers you should have gotten from A through F. If these are not the answers you got, maybe rewatch the earlier part of the video again and retry this, but you can always bring questions to class tomorrow as well. All right, so a little bit of a review, and this is mainly because I see students using words as if they mean the same thing even though they don't. So an atom is the smallest component of an element that still has its chemical properties, and it's made up of protons, neutrons, and electrons. For example, aluminum atom, Be, carbon atom, N. Meanwhile, molecules are made up of 2 or more atoms, and they are chemically bonded together. Types of molecules include diatomic molecules, compounds, formula units, etc. Examples: O2, diatomic molecule; H2O, compound; H2SO4, compound; ALP, formula unit. Molecules have more than one thing in them. Atoms only have one thing in them. So 1 mole of a substance is equivalent to 6.02 times 10 to the 23rd particles of that substance. Whether it's atoms or molecules, we're going to be calling them particles. So to convert between moles and molecules or compounds, you're going to use the conversion factor of 1 mole equals 6.02 times 10 to the 23rd particles. Let's look at an example together. How many compounds are in 2.34 moles of sodium chloride? So we would take the 2.34 moles of sodium chloride. We're going to use the conversion factor 1 mole, which goes in the bottom because we're trying to cancel out our moles. And we're going to put 6.02 times 10 to the 23rd compounds of NaCl on the top. And when we multiply, we should get 1.41 times 10 to the 23rd compounds of NaCl. We can do the problem in the opposite direction as well. How many moles are in 8.23 times 10 to the 32 molecules of water? So we put our 8.23 times 10 to the 32 molecules of water up first. This time we're going to flip the conversion factor in the other way because we want molecules to cancel out. So 6.02 times 10 to the 23rd molecules on the bottom, 1 mole on the top, and it will equal 1.37 times 10 to the 9th moles of water. So how many moles are in 9.21 times 10 to the 44 molecules of hydrofluoric acid? I want you to pause this video and try it on your own. All right, so you should have got 1.53 times 10 to the 21 moles. How many atoms in sodium are in 13.2 moles of sodium? Pause the video, try it on your own, and come back to check your answer. This time, you should have gotten 7.95 times 10 to the 24th atoms. How many atoms of oxygen are in 1 mole of phosphoric acid? Now, before you just start calculating, think about what the question is asking you. How many atoms of oxygen are in 1 molecule of phosphoric acid? Pause the video and come back when you have your answer. So you should have got the phosphoric acid is H3PO4, which means it has 4 oxygen atoms to answer the question. Now our last one is the trickiest. How many atoms of oxygen are in 18.9 moles of phosphoric acid? Hint, convert to molecules first, then convert to atoms. So pause this video and come back when you have an answer. You should have gotten 4.55 times 10 to the 23rd atoms of oxygen. If you didn't get these correct, you may want to rewatch the video. You can also always bring your questions to class tomorrow. Next thing we want to talk about is how we can convert from a volume to moles. So STP stands for standard, temperature, and pressure. Because gases behave differently at different temperatures and pressures, we have to be specific about the temperature and pressure of gas we are discussing. So our standard temperature is 0 degrees Celsius, and our standard pressure is 1 atmosphere ATM. So when you hear someone say STP, or standard temperature and pressure, they are meaning 0 degrees Celsius and 1 atmosphere. All problems are in STP unless specifically stated otherwise. So the volume, which we measure in liters as our standard unit, occupied by 1 mole of gas at STP is 22.4 liters. That is a number you need to know. So 22.4 liters of gas equals 1 mole of that gas at STP. That is important. So we can use this as a conversion factor when converting between volume and moles. So example 1, what volume will 5.99 moles of oxygen gas occupy at STP? So we take the 5.99 moles, we're going to use our conversion factor of 1 mole equals 22.4 liters of gas. We put 1 mole on the bottom, 22.4 liters of gas on the top, and once we do the math, we get 134.18 liters of gas. Let's try another example. If a gas occupies 0.176 liters of space at STP, how many moles of gas are present? Similar to last time, we are going to start with our number in our problem, 0.176 liters. This time we're going to use the conversion factor in the other direction because we want our liters to cancel out, 22.4 on the bottom. And once we do the math, we get 0.00783 moles of gas. All right, I want you to pause this video and try these two problems on your own. If a sample of carbon dioxide occupies 457 liters of space at STP, how many molecules of carbon dioxide gas are present? And number 2, a sample of gas was measured to contain 4.23 moles of gas at STP. What is the volume of this gas? So pause this video and come back to check your answers. All right. For number 1, you should have gotten 20.4 moles of CO2. And for number 2, you should have gotten 94.8 liters of gas. If you didn't get those right, you can re-watch the earlier section of the video or come to class with your questions tomorrow. All right, so we did each of these individually, and hopefully you're successful at it. But you have to be able to do them all mixed together. So I want you to pause this video, and I want you to try numbers 1 through 6 on your own. If you can't do them from memory yet, that's perfectly fine. You literally have your notes right in front of you. Go back, look at the section of your notes, and try these. The trick is being able to figure out what section you need to use in order to solve this correctly. Now keep in mind, on the next slide, I'm not showing you how I worked out these problems. I'm only going to show you the answer. So it is crucial that you work these out so you can be successful in this unit. So pause this video, try these 6 problems, and come back when you are done. All right, let's see how you did. These are the answers that you should have gotten, 1 through 6. If you aren't getting these answers, I really recommend you rewatch this video and come to class tomorrow ready to practice with this.